Morning guys, I'm here and I am going to be carrying out the lab where we will make t-butyl chloride from t-butyl alcohol via a nucleophilic substitution reaction. This reaction proceeds via an SN1 reaction mechanism. What happens in the first step is that the hydroxyl group is protonated by the acid and it leaves t-butyl alcohol as a neutral water molecule. What remains of t-butyl alcohol has a positive carbon atom. This positive carbon atom has an sp2 configuration about the center. The nucleophilic or negative chlorine atom, I shouldn't say atom, ion, will attack this positively charged carbon atom from either side of the molecule and form a new chemical bond. The product is now t-butyl chloride, where the chlorine is in the same position that the alcohol is in. I've already got my boiling water bath going, and now I'm going to start by adding my reactants. It says to take a small reaction vial, and the first thing I'm going to do is I'm going to take my t-butyl alcohol and I'm going to add 2 milliliters, okay? But using the density, I know that I need to add 1.6 grams.
Oh, you don't have class. Mike's got 1 out of his 6 officially blue kids here today.
Wow.
I've got 4 out of 8.
We're videotaping, Mr.
Oh,
Gottlieb.
sorry.
It's okay. Yeah, I'm waiting to see how many kids come today. But in the meantime, I'm going to do this live. I love it when Mr. Gottlieb walks in when I'm videotaping. Almost there. I'm going drop by drop because it's very close. I don't know why this isn't changing. Okay. There we go. Oh, never mind. Come on. I don't know what's happening here. I think that this is pretty volatile. I'm going to put the lid on, and then I have to go get my hydrochloric acid. Okay. Okay, here we go. Hydrochloric acid is nobody's friend. Should always be exceedingly careful. So I added 1.6 grams of the alcohol. And now using the density, I'm going to add 2.4 grams of the acid, which should be equivalent to 2 milliliters. I will, just enough. Keep these next to each other. All right. Have added exactly the masses that I'd like to. I've sealed the vial. I've made sure that the cap is on tight. Okay, now I'm going to shake the mixture. Looks pretty well mixed. And I'm going to add my copper wire handle. And I'm going to set this to start to boil. Not boil, but be heated by the boiling water. Okay, so let me get this going. There we go. There we go. Make sure that I can get this out. This is not tight enough. There we go. Better. Okay. It says to start this initially for a few minutes, 2 to 3 minutes. So set a timer for 3 minutes. My watch is unhappy because I have gloves on. There we go. After 2 to 3 minutes, I'll make sure that the reaction vial is still sealed tightly. And then I'll put it back in for a 20-minute incubation period. And I can actually already see bubbles coming out of the lid, which is bad. So I'm going to take it out, and I'm going to do this one more time. And make sure that it is on as tight as I can make it. Bubbles coming out of the lid is bad because the product has a really low boiling point. Still see bubbles coming out of the lid. This is just not good. So I've allowed this to cool. I'm going to put my gloves back on. And I'm like a little bit nervous here because I feel like I might have lost product already. But what I'm going to do is take some of this Teflon tape off of a bottle and wrap it around my reaction vial. Try to keep it sealed. See if that helps. Just hopeful that I don't have to do this again. Okay, I'm taking off my copper handle to try to seal this again. Trying to tighten it, and now I'm going to try and do this, and I should have done it from the beginning, but oh well, I should have thought about this. And here we go. wish me luck. There's already some vapor coming out, but I mean, I'm doing the best I can here, right? Well, I'm gonna let this go for 20 minutes. See what happens. I'll see you in 20. All right, it's been at least 20 minutes. This has been allowed to sit and cool. So now I'm gonna put it in my ice water. So I had some deionized water. I put it in the fridge overnight. Now it's 4 degrees Celsius. So this is my ice water. I just set a timer for 3 minutes. Okay, I'm putting gloves on, not for the next step, but for the steps after that. What it says now is that they want you to use a test tube and a cork stopper, but I know from previous experience it doesn't really go so well. So I'm going to try the set funnel today, see how it goes. So what they want me to do is they want me to add 5 to 10 mils of cold water. Okay, so here we go. Add 10. Really doesn't matter. Okay. Okay, so I have 10 mils. Put this on, off to the side, off to the side. And I think I'm going to find something that I can sit this in. I'm going to wait for the 3 minutes to pass. And when the 3 minutes passes, I'm going to carefully observe what's in my reaction vial and note that there are 2 layers. The lower layer is the aqueous layer. It contains anything that's unreacted, so that could be hydrochloric acid and t-butyl alcohol. The upper layer, supposedly, contains my product, t-butyl chloride. I'm going to use my Pasteur pipette, and I will carefully remove the upper layer from the reaction vial. And slowly, I will add this upper layer to my set funnel containing the ice water. Right? Now I say supposedly because I saw lots of bubbles no matter how tightly I capped this, and I even wrapped it in Teflon tape. So I don't know, maybe that'll just be apparent if in the end when I do percent yield. But I hope that we got some decent product formation so that we can measure boiling point once we're all done. Okay. Still waiting. About 10 more seconds. Here we go. So again, I'll undo the copper handle. Let's see how I do here. Probably should have a paper towel. Okay. I will carefully observe my contents. I'm going to look closer to you. I'm hopeful that maybe you can see that there are 2 distinct layers here. I will take off the Teflon tape. Okay. Here we go. I'm going to set this down. Go. Carefully remove one and add it to the other. carefully add it to the side here. Continuing. I have a little bit left. Let's see if I can get it. I think that's good enough, guys. Okay. I'm gonna put this down. I'm gonna put this down. I'll eventually neutralize it in my sodium carbonate. Okay. So now what I'm going to do is add the cap here. Okay. And I am going to carefully invert this. 1, 2, 2. I'll do it 3 times. Okay. Good. All right. I vented it. I'm going to let it sit for a moment. Okay. While I let these layers settle, okay, I have a second reaction vial. Clearly have an upper layer here. Now I could do this in one of 2 ways. The purpose of a sep funnel is to be able to drain and separate 2 layers. So what I can do here is I can carefully drain the lower water layer as best I can. This would drain. Don't know why it's not. I guess there's an air bubble maybe. It's going, it's just slow. This is very frustrating. Okay. Good point. I should take the
It's a little, probably so tight it doesn't.
There we go. Thank you, Mr. Gottlieb. Hold on, go slow, 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 slow. Perfect. Okay. I'll take what remains. Uh-oh, this is going to be a challenge. What do we think? Do you think I can do it? I think I can. Is it in the camera? It is. Slow. Let's see if I can get it in here, guys. There we go. Look at that. Perfect. All right. I did it. Ooh, it smells. It's a good sign. So here we go. You can see I have a little bit of aqueous layer. It's fine. I'm going to dry it now to get rid of it. I'm out of the camera. There you go. I'll be back in a moment. All right, I'm back. I have my magnesium sulfate that I'm going to use to dry my product. Hopefully I'll get rid of that little bit of aqueous layer that came over, similar to what we've done before. I'm going to take a small amount, just enough to cover the bottom of my test tube vial. Let's see what we have here, maybe a little bit more. There we go. Okay. A little bit more. There we go. So you can actually see that this magnesium sulfate is bubbling a little bit. It means that the sulfate anions are reacting with the acid. All right, I think I'm good here, guys. I think I'm good. So what I'm going to do now is transfer what I've got here to a clean, dry reaction vial. And I'd like to, if it's possible, to turn this on. Try to measure the mass of product that I made. Still has that odor. It's very volatile. I just lost a little bit of it here, but that's fine. Hopefully I'll still get the mass because it's on the balance. Go. I have 0.99 grams here. 0.99 grams. Okay. We can use that mass to calculate a percent yield. And then what we'll do now is test its boiling point. Hey guys, we're back. I am ready to do my boiling point test. I've heated up my water bath. It's at about 55 degrees Celsius, a few degrees above the literature boiling point for our product. I'm going to move this thermometer out. And then over here, you guys can see, hopefully, that I've set up my boiling chamber. So I have my t-butyl chloride and my broken piece of capillary tube and my microscale test tube. And I'm going to try to lower it in. And hopefully it should start to boil. I can see the bubbles actually, so that's good. Yay. Yay, it's definitely boiling, so that's good news. And I'm going to zoom this in so that maybe you can see the bubbles. I'm watching the temperature, it's dropping, we're at 54. You're either gonna watch the bubbles, which you can see pretty clearly now, or the temperature. We can't see both from this far away. So I'm gonna kind of like give you a play-by-play. We're at 54.0. The only thing we can hope for is that the whole thing doesn't evaporate away before we reach the boiling point. But it's kind of like going slow and steady. And the temperature is also dropping slow and steady. So we might be here for another 2 minutes just watching these bubbles. It's kind of hypnotic. You find your Zen place. 53.7, still boiling. Keeping my fingers crossed that it boils at the right temperature. I think I did a pretty decent job at getting rid of the aqueous phase, so shouldn't be like a mixture, but that would play a role if you guys were looking to discuss error. If I had some aqueous phase in there, it would definitely affect my boiling point. I'm down to almost 53. It's 53.1. Seems to be decreasing at a better rate now, 53.0. And if you look, the formation of bubbles is starting to slow. So that's also a good sign. And then of course, as I see that, it looks like maybe, I don't know. I think it's slowing down. We're at 52.9. I don't know. 52.8. I do think it's slowing now. I am starting to get concerned because the volume is getting a little low. 52.6. You guys can still see that. I just hope that we don't run out. $52.3. Okay. Almost done. Up. 52.0. It stopped. That's amazing. I can't even believe that just happened. 52.0, guys. What can I say? I'm pretty good at what I do. I'll help you guys with your write-up later. Bye.